All right, these are two special rational functions that we're going to be dealing with here. So our first one, we don't have any vertical asymptotes. And how you can tell there are no vertical asymptotes is if we set this equal to 0, we say that x squared plus 1 equals 0. And if we solve that, we get x squared equals -1. Square root. It's imaginary. But you can also just look at it and see that if you square any number, it's going to turn positive. And then we're going to add it to another positive. Well, a positive plus a positive is a positive. This is never going to be 0. In fact, it's never going to be negative, that denominator. The denominator will always be positive. So our domain here is from -infinity to +infinity, which means we have no vertical asymptotes, no holes. So that would be none here. We have no vertical asymptotes whatsoever. So you still find the x-intercepts and the y-intercepts the same exact way, but we're just doing asymptotes for these special ones. And so what we still have is that horizontal or vertical. So our top is x cubed, and we're dividing it by x squared plus 1. And so this one we actually do have to divide in normally because we are dealing with an x squared plus 1. That is not factorable, does not cancel, and so we have to do a normal long division here. So x squared times what? That would be x, and so we get x cubed plus x by distributing, and then we change the signs, and then those cancel like we're going for. We don't have to worry about that one, and so we get -1x, bring down the 1, and we do it again. Now x squared cannot go into this, so we're done. That's it. There's nothing I can multiply x squared by to get -x. And so we end up with x plus, and then it would be -x plus 1 over x squared plus 1. But we don't care now. Our bottom degree is bigger, so this one goes to 0. So what we end up with is y equals x. So that makes our horizontal y equals x. So now we can place that on here like that. I told you these are special. These are the cool ones. All right, and then we plug it in the graph to see what's going on here. So I've already done that. Hit zoom 6 so you can see it graph. And so you can see that line, and then it curves right in here. Now, just to get that graph to make sure it matches our asymptote, let's put y equals x on here and hit graph. And you can see it's following right there and there perfectly, just like we were talking about. So this is the graph. So now we just have to graph it. So it's approaching over here like that, and then it curves in and then curves over there and does that. So you're just tracing that graph on there like that. And again, you can plug it in and do data points to get the exact graph, but you can see our graph goes like this and then approaches that way, -infinity, and then approaches towards +infinity with infinity. And that's your graph. So this one's special because there is no vertical asymptote, and we're getting a slant asymptote here. So we don't have that line sitting here where it does this and this. And so it really just comes in and connects through the middle. All right. This next one is one I told you we'd talk about before. So when we start any of these, we're supposed to factor. That last one was not factorable. So the top factors into x minus 2, x plus 2, all over x plus 2. And then we cancel the x plus 2, which gives us x minus 2. So if you remember that thing we cancel, that's our hole. So we have a net hole at -2 comma, and this is our new function. So we'll call it g of x is equal to x minus 2. That's what we're really graphing. We're going to be graphing y equals x minus 2. So that would be here, -2 right there, up 1 over 1, and then you draw the line. Let me make sure it looks nicer. We're following that slope of 1 so that it makes sure it stays on that slope of 1. Okay, so there's our graph, but there's a hole on this graph. So if we take that -2 right here and we plug that in, we get a -4. So -2, just like we have, that's our hole. So I like to fully put the hole first and then draw the line. That way there is nothing there. So now if we check this in our calculator, everything should work out perfectly. So I've already plugged it in. We hit graph. And you can see there's no hole here. But if I hit trace -2 and hit enter, there's nothing there. So there really is nothing there. If you hit trace, see, we go towards this, there's numbers. It won't do it. There's numbers on the left, there's numbers on the right, but at -2, there's nothing because it's a hole. So they won't even put a dot there. So that means our domain here is from -infinity to -2, union -2 to infinity. So if you want to introduce a hole into any function, just divide it, multiply it top and bottom by that thing, and it'll create that hole. All right, these are your special ones. Thanks.